When transitioning from a plastic water system to copper piping, particularly at a water heater, it's important to understand the bonding requirements to ensure electrical safety. The purpose of bonding is to create an equipotential plane, meaning that all metallic components are at the same electrical potential. This minimizes the risk of electrical shock if a fault occurs. The minimum length of copper pipe allowed before bonding is required is 5 feet. This means if you have less than 5 feet of copper pipe connected to your plastic water system, bonding may not be immediately necessary. However, it's crucial to consider the specific requirements of your local electrical and plumbing codes, as they may have more stringent rules. A reason for this regulation lies in the potential for the copper pipe to become energized. If there's an electrical fault somewhere in the building, such as a damaged wire contacting a metallic water pipe, the copper pipe could become live. Without proper bonding, a person touching the energized pipe could experience an electrical shock. Bonding the copper pipe to the grounding system of the building provides a low-resistance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse, interrupting the flow of electricity and preventing a dangerous shock. Here's a breakdown of the key concepts. Firstly, bonding refers to the practice of connecting metallic parts of a system together to create an electrically conductive path. Secondly, grounding involves connecting the bonded system to the earth, providing a reference point for electrical potential. Thirdly, the National Electrical Code, or NEC, provides guidelines for bonding and grounding electrical systems, including those related to plumbing. When installing copper pipe in conjunction with a plastic water system, several factors influence the bonding requirements. 1. The length of the copper pipe is a primary consideration, as mentioned earlier. 2. The proximity of the copper pipe to electrical equipment or wiring is also important. If the copper pipe is located near electrical panels, outlets, or other electrical components, bonding may be required regardless of its length. 3. The type of plastic pipe used in the system can also affect bonding requirements. Some plastic pipes are more conductive than others, and this can influence the overall electrical characteristics of the system. To ensure compliance with electrical codes and to protect against electrical hazards, it's recommended to consult with a qualified electrician or plumbing inspector. They can assess the specific installation and provide guidance on the appropriate bonding methods. Here are some common methods for bonding copper pipe. Firstly, using a bonding jumper. A bonding jumper is a length of copper wire that connects the copper pipe to the grounding system. The wire should be sized according to the electrical code and securely attached to both the copper pipe and the grounding electrode. Secondly, connecting to a grounding electrode conductor. The grounding electrode conductor is the wire that connects the building's grounding system to a grounding electrode, such as a ground rod or metal water pipe that is in direct contact with the earth for at least 10 feet. The copper pipe can be bonded to the grounding electrode conductor using a suitable connector. Thirdly, utilizing a metal water pipe as a grounding electrode. In some cases, a metal water pipe can serve as a grounding electrode. However, it's important to ensure that the water pipe is electrically continuous and that it meets the requirements of the electrical code. In addition to bonding the copper pipe itself, it's also important to bond any other metallic components in the plumbing system, such as metal fittings, valves, and supports. This helps to create a comprehensive bonding system that minimizes the risk of electrical shock. When working with electrical systems, it's essential to prioritize safety. Always disconnect the power before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and eye protection. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. In summary, the minimum footage of copper pipe allowed before bonding is required in a plastic water system is generally 5 feet. However, it is important to consult local codes and a qualified professional to ensure compliance and safety. Understanding the principles of bonding and grounding is crucial for protecting against electrical hazards and ensuring the safe operation of plumbing systems. Remember that bonding is a critical safety measure that protects people from electrical shock. While 5 feet is a general guideline, local codes may have stricter requirements, so always check with your local authorities. Electrical codes are constantly being updated to reflect new technologies and safety standards. It is important to stay informed of any changes that may affect your plumbing system. Moreover, it is important to remember that proper bonding not only protects people, but also helps to prevent damage to electrical equipment and appliances. Electrical surges and faults can damage sensitive electronic components, but a properly bonded system can help to divert these surges and protect your equipment. Beyond the technical aspects, ensuring proper bonding and grounding can also provide peace of mind. Knowing that your plumbing system is safely grounded can help to alleviate any concerns about electrical hazards. Don't hesitate to contact a qualified electrician to assess your system and make any necessary repairs or upgrades. Furthermore, consider the impact of future modifications or additions to your plumbing system. If you plan to add new fixtures or appliances, make sure that they are properly bonded and grounded as well. Integrating new components into an existing system can sometimes create unforeseen electrical hazards, so it's important to take a holistic approach to bonding and grounding. Bonding is also a critical consideration in commercial and industrial settings where the risk of electrical hazards may be higher. In these environments, it's essential to have a comprehensive bonding and grounding plan in place to protect employees and equipment. Working with a qualified electrical engineer can help to develop a customized bonding and grounding strategy that meets the specific needs of your facility. Also note that certain types of plastic pipes may require special bonding considerations. Some plastic pipes are more susceptible to static electricity buildup, which can create a fire hazard. In these cases, additional bonding measures may be necessary to dissipate the static charge. In addition to adhering to electrical codes, it's also important to follow manufacturers' instructions when installing bonding and grounding components. Using the correct hardware and installation techniques will ensure that the system functions properly and provides adequate protection. When selecting bonding and grounding materials, consider the environmental conditions in which they will be used. Corrosion and moisture can degrade bonding connections over time, so it's important to choose materials that are resistant to these factors. For example, using stainless steel or copper components in corrosive environments can help to extend the life of the bonding system. Regular inspections of your bonding and grounding system can help to identify any potential problems before they become serious. Look for signs of corrosion, loose connections, or damaged components. If you find any issues, have them addressed promptly by a qualified electrician. Finally, remember that bonding and grounding are not one-time projects. They are ongoing maintenance tasks that should be performed regularly to ensure the continued safety and reliability of your plumbing system. Taking the time to properly bond and ground your plumbing system is an investment in the safety and well-being of yourself, your family, and your property. A well-bonded system provides a low-impedance path for fault currents, allowing protective devices to quickly trip and clear the fault. This rapid response helps to minimize the duration and severity of electrical shocks, reducing the risk of injury or death. Proper bonding also helps to prevent the buildup of static electricity, which can ignite flammable materials. In environments where flammable liquids or gases are present, static electricity can pose a significant fire hazard. Bonding metallic components helps to dissipate static charges, reducing the risk of ignition. Furthermore, bonding helps to protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can occur due to lightning strikes, power grid fluctuations, or the operation of heavy equipment. By providing a low impedance path to ground, bonding helps to divert these surges away from sensitive equipment, preventing damage and downtime. Proper bonding can also improve the overall performance of electrical systems. By minimizing voltage drops and reducing electrical noise, bonding helps to ensure that equipment operates efficiently and reliably. In addition to the safety and performance benefits, proper bonding can also help to maintain the value of your property. A well-maintained electrical system is an asset that can increase the value of your home or business. Potential buyers will appreciate the peace of mind that comes with knowing that the electrical system is safe and up to code. In conclusion, bonding and grounding are essential aspects of electrical safety that should not be overlooked. By understanding the principles of bonding and grounding, and by following the guidelines of the electrical code, you can protect yourself, your family, and your property from electrical hazards. Remember to consult with a qualified electrician or plumbing inspector if you have any questions or concerns about bonding and grounding. They can provide expert guidance and ensure that your electrical system is safe and compliant with all applicable regulations. The NEC specifies requirements for sizing bonding conductors based on the size of the overcurrent protection device protecting the circuit. Ensure that the bonding conductor is adequately sized to handle the potential fault current. Also be aware that certain types of plastic pipes, such as CPVC, may have different bonding requirements than other types of plastic pipes, such as PVC. Check the manufacturer's specifications and consult with a qualified electrician to determine the appropriate bonding methods for the specific type of plastic pipe used in your system. When bonding metal water piping systems, it is also important to bond any gas piping systems that are present. This helps to prevent stray currents from flowing between the water and gas piping systems, which can cause corrosion and other problems. The bonding connection should be made as close as possible to the point where the gas piping enters the building. Moreover, remember that bonding is not a substitute for proper wiring practices. It is still important to follow all applicable electrical codes and standards when installing electrical wiring. Bonding is simply an additional layer of protection that helps to minimize the risk of electrical shock and fire. It is good to consider the use of surge protective devices, or SPDs, in conjunction with proper bonding and grounding. SPDs are designed to protect sensitive electronic equipment from damage caused by voltage surges. They work by diverting the surge current to ground, preventing it from reaching the equipment. SPDs are particularly useful in areas that are prone to lightning strikes or power grid fluctuations. Also, it is important to be aware of the potential for galvanic corrosion when bonding dissimilar metals. Galvanic corrosion occurs when two different metals are in contact with each other in the presence of an electrolyte, such as water. The more active metal will corrode, while the less active metal will be protected. To prevent galvanic corrosion, use compatible metals or install a dielectric union between the dissimilar metals. The dielectric union will prevent the flow of current between the metals, minimizing the risk of corrosion. When making bonding connections, use approved connectors that are designed for this specific application. Ensure that the connectors are properly tightened and that they provide a good electrical connection. Loose or corroded connections can increase the resistance of the bonding path, reducing its effectiveness. Finally, remember that electrical safety is everyone's responsibility. If you see something that looks unsafe, report it to a qualified electrician or building inspector. By working together, we can create a safer environment for ourselves and our communities.